Hello and welcome to my channel. Today I'm going to talk about modeling functions. I'm going to touch on the basics of callbacks and how would you call certain functions on demand, which will be an introduction to the strategy design pattern. I will try to make this tutorial as short as possible because otherwise it will be an incredibly huge video, which I'm not, which I think it's not a proper way to teach stuff, especially in the introduction way. So I'm going to be quicker than the last video that I have made. So let's get to it. Imagine that you have a couple of functions. These functions usually have the same signature, which means they have the same parameter types and they have the same return value. I've made a couple of examples here, like you take like a number and you square it, or you take a number and you make the square root of that, or you divide it by 2. Okay, so for example, here are the definitions of such functions. Like you have a v value, you square it here, or you have a v value. I'll suppose that the value is positive, okay, just for simplicity. Or you can divide the value by half and return it, of course. Okay, now supposedly you want to change the function that you want to execute in runtime. How would you do that? Well, there is something called function prototyping in C++11. I don't know what do they call it, but it works like this. You include the here it is. You include the functional header, which is available in C++11, and after that you create a model of your possible function. Okay, so here in this tutorial, in this case, we say that we want a function which takes double, which returns double as its return type, and which takes double as its parameter, and we call this, which is actually a pointer to a function, we call this func, or whatever you want. Okay, so what I'm going to do now is I'm going to enter a double value here, and I'm going to say that the first function that I'm going to apply on that value, on this v, is the square value, which is this one. Okay, so here you see that this function, the square function, takes a double as a parameter and returns a double. So in this case, I'm going to square the number. After that, I'm going to change the address of the function that I'm going to call. Since func is an address of a function that takes double and returns a double, then I can do the same thing that I have done here. Okay, so I can do this by changing the address of that function and call the square root function. Okay, and in that case I will show the values, and after that I'm going to change again the address of that function and divide the value that I have by 2 using the half function, which is this one. Okay, so again, the functions have the same signature, so it's very easy to change the address of the function pointer that is calling them. Well, this is actually the new way to do things in C++11. It's much easier than using the traditional pointers to function that we used to do in C++98 and in C. So let's see how things now are going to look. So let me rebuild this stuff. What is this? What? Build. Okay, and let's run. So now let me try value like say 9. Okay, so First, I squared I squared 9, which produced 81. Then I square rooted 9, which I got 3, and then I've divided 9, and then I got like 4.5. Okay, so let's try this again with another value. Supposedly, I don't know, 78. Okay, so the square is something, the square root is another thing, and the half is what? Yep. Okay, so I suppose that the half of 78 is 39. Okay, so obviously this thing work. Now I'm going to show you something else. This is a very easy example that doesn't exactly show the power of this technique. Since I've prepared this tutorial before, so I've created already the structures and the classes, so I don't have to type them during the tutorial, which would make the tutorial very long. So I'm going to describe the architecture right now. Supposedly you have a game entity, okay? You want to create a game, and all your objects in that game are descendants of a class called game entity, okay? Which is anything, okay? Now, from this game entity, you derive another class which is called enemy, and which is abstract because it has some parts of its public interface as abstract, which means you cannot instantiate any instances from this class. But the main point is this: from this class, from the enemy class, you declare you subclass another class, which you call it like tank, and another subclass which you call it like fighter jet, okay? And there you define this abstract method in your some way. So if I just delete this, and if I go to the declaration part here, the constructor just say that you have created a tank. The destructor tells you that you have destroyed the tank, only to show you the polymorphic behavior of this architecture. Okay, so here the shoot interface for the tank is like fire the high explosive shell. And for the fighter jet, you say something similar, anything you want, like fire the guided missile. Okay. Now I have three functions here. I have three functions, which each one of them creates me something like an instance. But those instances are like pointers to base class, which is class enemy. Okay. So they have actually the same signature here. Those two functions, create tank and create fighter jet, have basically the same signature. They both return me a pointer to a base class, which is the enemy class, and they take nothing as parameter. Okay, then I have a free function, another free function, which creates me some game object based on some parameter. Okay, and it returns to me that pointer to the enemy instance. Okay. And this is a small utility function that I use to delete the pointers that I create. So what happens here? The create tank function just creates a pointer of a tank and returns it as a pointer to enemy. Okay, which is very usual in polymorphic hierarchies. The same for create fighter jet. It just creates an instance of fighter jet and returns it. It returns it as a pointer to enemy. And then here are the fun things. The create game object receives a parameter, which is the object type. Okay, so here I'm creating a pointer to a function, and I'm telling this pointer to function that you point to functions who return pointers to enemy instances and who take nothing as parameter. Here you say there is nothing here, and there is this pointer to enemy instance, which is the return type. Okay, so after that I'm just checking what type of object I'm going to create, and based on that, so for example, if I receive 1, then I assign the pointer function to the address of the create tank function, and I return I call that function, and I return the pointer that had that function returned. Okay. The same in the case when I receive 2 as a parameter, I change the address of this function to point to the create fighter jet function, and I return the pointer that it returns after calling. Okay, and for default I do nothing, and this is all just for simplicity. Okay, you can do very, very interesting things with that, and I'll explain them in a bit. So here is the main stuff. I'm going to comment this section. So what I'm going to do here is that I'm creating a vector of enemy pointers, and I'll call it objects list. I need a character to check for the keyboard input, and here I'm telling the user to choose either inputting 1 or 2 to create a tank or a plane, or Q to quit. And we go. Okay, so we just enter a character, and we check if that character is quitting or not, and if it's not, then I just check the value of that character, convert it to an integer, and after that I'm pushing back into the vector a pointer that I create using this function. Okay, so which is create game object, which we discussed just a couple of minutes before, and that create game object receive this this input parameter to decide what kind of objects I'm going to push into the objects list. Okay, so we can try it now. Oops, what happened? Multiple definitions of I'm not sure about that. Yeah, maybe I should do this first. Guessing this is something to do with virtual pointers, etc. We'll see. Here, like this. Okay. Let's clean it first and rebuild it. Yes. Okay. So for the main program, of course, I need the strings, the IO stream, the vector, and the algorithm. Right. So let's run it. So here it asks me to input 1 or 2 to create a tank or a plane. We have 1 for tank and 2 for a fighter. So a tank instance created, a tank instance created, a tank instance created. Let's try 2. Jet fighter instance created. Okay, another one. Jet fighter created. Let's input 1. Okay, a tank instance created. And now let's quit it and see. So how much instances we had? 1, 2, 3 tanks, 2 fighters, 4 tanks. Okay, so This is a technique to create objects on demand. It depends on the situation that you have at hand. Okay, supposedly you are running in an infinite loop, in a game loop, for example, and you want to create entities there in your game, but you, for some reasons, you want to limit the amount of tanks that you create. Okay, or let's say the extraterrestrial enemies. You want to create more planes. So in that case, based on your situation, you change the algorithm that you are going to use. Here is another example that I didn't write here. Okay, supposedly you have a list of objects, and let's say you have like vector of my objects. Okay, pointer my list. Okay, now supposedly that based on the number of elements that you have, okay, say size, okay, supposedly that you want to sort them. Okay, now if the number of elements that you have there is very big, say million elements, or 10 millions even, okay, then this is, for example, a critical situation and you want to sort your the list very fast. Okay, like my list, I don't know, sort quick sort if they have, or you could probably implement your own algorithm for such situations. Okay, if, for example, the number of elements is moderate. Okay, so in this case, let's say you use the function. Your function probably would be like a pointer to quick sort, which is anything, something like that. Okay, quick sort and my list, something like that. Okay, and if you have a moderate number of elements, supposedly something like that, okay, then you would do f would change into, let's say, merge sort or whatever. The point of what I'm trying to make is that based on some situation, you change the algorithm that you want to execute in that case. So if you have like too many elements to sort, you use the fastest algorithm you have. If you have a moderate number of elements to sort, then you use something less critical. And because you are not caring about performance, you can do more effects, for example. Okay, so this is the point of using callbacks and function pointers the way the C++11 is doing now. It's very easy and it's more fun to do than the old way. And this concludes probably the tutorial of today. If you have any questions or anything you want to know, please leave a comment below. Thank you for watching.